Here we are going over a key for the recent forces test. It begins with a child holds a hamster in her hand. Now remember, your questions will be scrambled in terms of sequence, and the answers choices or alphabet letters for them will also be scrambled. So you want to look at the meaning rather than the alphabet letter. The reaction force to the weight of the hamster is your challenge. So you need to get it into a 3-word sentence with pushes or pulls in the middle. This says earth pulls hamster. That's what the weight of the hamster is. Therefore, the reaction force is going to be hamster pulls earth. And that's the choice, hamster on earth. There was one about an astronaut on another planet named Quinn. And in this case, we're given Quinn's weight on planet Earth in newtons. So we have to calculate Quinn's mass. And once we get that mass of almost 63 kilograms, we then rearrange the same weight equation so that we can solve for G. This time we put in the new weight that Quinn has on the other planet and divide by mass. And once we have that done, we can get G, which you might call G prime because it's different from Earth. This particular one is 7.195, so I choose 7.2. There was another one that was about 6.4 and one that was 6.7. And you had to choose the one that was closest to the acceleration that you calculated. I do have multiple forms on these. This is a 99 Newton box sliding down a ramp at constant velocity. So constant velocity tells us the net force is 0. The free body diagram has 3 forces on it, but an important part of it is the component called W parallel, because that's the one that's parallel to the box's acceleration. And friction is opposite that direction of motion. So you can see I have net force is 0 because of constant velocity. That's why it's highlighted. Those are magic words. And I have negative friction plus W sine theta because that's our equation for W parallel. It's opposite the angle right there formed by the component triangle that you draw. So this gives us a frictional force equal to W sine theta, just in the opposite direction. So here it's 52. On another form, the angle was different. And so you had a 42-degree angle, and that frictional force was 66. Here's another Newton's third law question. This says a senior pushes a freshman, and like the questions I've seen on the AP exam, it has a lot of extraneous information there just designed to throw you off your game. And what you have to do is focus on the fact that this is third law and boil everything down to a 3-word sentence. If senior pushes freshman, the reaction force is freshman pushes senior. And those forces must be equal in magnitude. So if the push is 100 newtons from the senior, the push is also 100 newtons from the freshman. On another form, the push was a different magnitude, so they had to be equal again, force of 50 for the reaction force. Turning the page here, we have an elevator problem. And in this problem, we are told that the weight of the person is not, if we can calculate it, the true weight. That is, the scale reads a number, in this case, that's light. I use W is equal to mg to find the weight of the person. And then right there, I have 480 newtons, so I know it's reading light. So which of the following 2 statements must be true? I've got to have a negative number for acceleration in order to make the reading on the scale come out negative. You can see the free body diagram, the net force equation, looking just as it does in your notes to calculate the reading on the scale. And we cannot tell if it's moving up or down because it's possible to have negative acceleration going downward faster and faster or going upward more slowly. On the other version, we had a weight that was suspiciously heavy. That is, the scale was reading more than the person's actual weight. So we might say this scale is reading heavy because it was showing 520 newtons for a person that's about 500 newtons. So when we do the same process we did just a minute ago, we conclude this acceleration must be positive. Therefore, that acceleration is uniform and upward or positive. If the elevator were moving at a constant rate, the scale would be reading the person's true weight. No problem. The next problem here has 2 force vectors at right angles to each other. So you have to use the Pythagorean theorem to get the net force. Like almost every problem on the AP test, it's a 2-step problem. Once I have net force, I have to realize I still need acceleration. So I go to Newton's second law, and I take the net force, which turned out to be 17, and divide by mass to get that acceleration. So on another test, there was a 61. And you can see I did the inverse tangent here. to get the angle, but I really don't need that. The number that I'm given is the only one that it could possibly be. In the next problem, a pumpkin is being pushed. So here's the pumpkin, here's the push, friction in the opposite direction. Net force in the x direction is of interest. So I list the forces in my diagram. You don't, of course, have to show this work, but it's the way to get the right answer. Friction is mu times the normal force. Those are balanced, so normal and weight are equal to each other here. And I have opposite signs, and I solve for mu, 0.356 on this form, and it was 0.311 on another form. So the numbers varied in terms of the directed force, the horizontally directed force that produced that velocity. Here is a problem that occurred only on some forms, and this was sort of matched according to which free response you had. So if you did not have a dragging box on the free response, you had a dragging a box problem on the multiple choice. And here's the diagram for it, and we have to balance the vertical forces here because they're asking us about the normal force. So there are two ups here. There's a component here that you can't see until I draw it right now. That's the up component that we're going to call PY. It is opposite the pulling angle, therefore it's related by the sign. And so when I work with that and I realize, the normal forces must be balancing normal and PY with weight because it's not flying up in the air. So net force in the Y direction is 0. Those two things right there are going to give me the normal force, and I choose that one. So you have to watch your signs. Make sure your ups are positive and your down is negative. If you did not have that problem, you had a half Atwood, and that's because people who got this problem did not have an Atwood problem on their test. People who got the other problem did have an Atwood problem on their test. So you don't have to worry about all of this. I just put it up there in case you wanted to pause the video or look at it, because there's no friction here. There's no worries at all. So all you have to look at is net force divided by mass, but it's algebraic. Again, quite typical for the AP exam. It's not so much numbers as it is alphabet letters. So I have a box of 2 and I have a box of 6 connected to a 2. Therefore, when I do this, I have 2/8 times G, or 1/4 G, and that's my choice. You then had a hanging sign problem. Everybody had this one, or something like some version of it. So the net force in the Y direction has to be 0 because we don't want the sign to come crashing down. And this is that branch of physics we called statics in your notes. So mass times acceleration is 0. I have this Y component up. This is Ty right here. And I have the weight coming down. This is opposite, this Ty right here, the Y component, is opposite the angle that I know. Therefore, I'm going to use the sign to find it. So when I rearrange, the tension is the weight divided by the sine of the angle. So that one was 70.54, rounds up to 71. Here's another form that just had a different angle. In this case, the sine of 36 was the denominator. Moving to the next page, we have a weight hanging from a spring scale from the ceiling of an elevator. So we go back to our notes on that one if you need to review this. And it's the force of the scale up, the weight down. And a little bit of a complication here is that we have weight, but at some point we need mass because we have to use mass times acceleration. So remember, weight divided by 9.8 will give us that mass. So here's our mass times acceleration. An important point to get is that this is a downward acceleration. Therefore, you have to use a negative acceleration, and that will give you the correct answer here. On another form of the test, another form of the test, you just had slightly different numbers, but wait a minute, this is a completely different problem, isn't it? These people had a sliding box in the back of a truck in their multiple choice. The people who had that problem had a sliding box in the back of the truck on their free response. So I was conscious about matching difficulties. So here's the sliding box problem. The only horizontal force when that driver hits the brakes is the force of friction. And it's in the backwards direction, by the way. So I set them equal to each other. And when I do that, I can solve for acceleration like that. Notice that the masses cancel out. It doesn't really matter what mass that box has. That's going to be its acceleration. So that's the multiple choice test. I hope that helps you. Make sure you do some studying. You'll see those things again on final exams as well as the AP exam.